Hello and welcome. In this video we're going to go through the division of two complex numbers in polar form. So suppose I have a complex number z1 is equal to r1 cis theta, and another complex number z2 is equal to r2 cis another angle phi. Then how would I go about finding the quotient of z1 on z2? Well, when we're dividing two complex numbers, we never actually carry out a division process. What we do instead is multiply the numerator complex number, so z1, by the inverse of the denominator. And in a previous video I've already gone through this process in Cartesian form, and I'll link a video in the description to that. But in this video we're going to go through the same process in polar form. Now, in my last video we found that the inverse of z2 can be expressed as 1 on r2 outside of cos phi minus I sine phi. So here is our divisor z2, and here is the inverse of z2. So let's carry out z1 multiplied by the inverse of z2. So this is equal to now r1 outside of cos theta plus I sine theta multiplied by 1 on r outside of cos phi minus I sine phi. So this should be a 1 on r2. Okay, so I can take the r's out the front, so I get 1 r1 on r2. Then I can simply distribute the cosines and the sines out. So I get cosine of theta multiplied by cosine of phi minus I cos theta sine phi plus I cos phi sine theta, and minus I squared sine theta sine phi. And simplifying further, the I squared is a -1, and so we get minus -1. So I can combine cosine theta cos phi plus sine theta sine phi as the real component and the imaginary component, so I get minus I outside of cos theta sine phi minus cos phi sine theta. And again, knowing our trigonometric identities can really help us simplify this expression here. So this real part here can be simplified to cos of theta minus phi, and the imaginary part can be simplified to sine of theta minus phi. And the identities that we've used here are called the sum difference formulae, or the sum difference formulas. So we still have r1 on r2 outside of cos theta minus phi minus I by sine theta minus phi. So finally, if I write this out neater, I get z1 divided by z2 is equal to r1, the modulus of z1, divided by r2, the modulus of z2, by cosine of theta minus phi, so cosine of the difference of the two arguments, minus I by the sine of the difference of the two arguments. Alright, so let's do a quick example. Z1 divided by Z2 is equal to 10 cis 60 degrees over 5 cis negative 30 degrees. So our formula for dividing two complex numbers is Z1 over Z2 is equal to R1, the modulus of Z1 over R2, the mod of Z2, cis theta 1, the argument of the numerator complex number, minus theta 2, the argument of the denominator or the divisor complex number. Okay, now it's simply a matter of plugging in the values. So R1 is 10 over R2, which is 5, then cis, and the first argument is 60 degrees minus, and the second argument is negative 30 degrees. And 10 over 5 is of course equal to 2 by cis, and then 60 minus negative 30 degrees is 90 degrees. So we have 2 outside of cosine of 90 degrees plus I sine 90 degrees. Cosine of 90 is equal to 0, and sine of 90 is equal to 1. So we have 2 outside of 0 plus I times 1, which of course is equal to 2I. So that's division of complex numbers in polar form. If you have found this video useful, please give me a like, and please feel free to subscribe to my channel for more helpful math tutorials. In the meantime, best of luck, and I'll see you on the next video.